Okay, so remember what this review number 2 is all about. It's fractions, basically. They call them rational expressions. Just means ratio, one thing over the other. So rational expressions, fractions, basically adding, subtracting, multiplying, dividing. So we want to subtract those two fractions, rational expressions. And so how do we do it? There's something about these two fractions which makes them nice. And they won't always be that way. Yeah, same denominator. You're seeing it. Exactly. Same denominators, huh? Their bottoms are the same. Yeah. So that's super nice. So I really don't have to do a lot. It just keeps the same denominator, doesn't it? You don't have to do anything with the denominator. It just keeps that same denominator. And then on the top, we just subtract them, right? Can you do that real quick? Can you just make it all one big fraction? Just combine the 3x plus 8 and then subtract the 2x minus 1, right? And put it all in one big line up there. Let me give you just a second up there. What is that going to look like? Well, what it'll do, it's 3x plus 8, no big surprise there. Now watch this closely. This is a real easy mistake to make that a lot of people make. Minus 2x minus 1. That's actually wrong. Probably a lot of you got it correct. Why am I wrong there? What am I doing that's wrong? I bet some of you know. What is it? Yeah, change that sign to plus 1. Huh? So everybody see that? Because this minus sign, really, I don't want to take two steps, but really it means, this. Let me erase that. Here's what it really means. I didn't want to bother to do that and then do a second step. But that's why it changes, because you're subtracting all of the 2x minus 1. Yeah, all of the 2x minus 1, right? Not just the front part, so that changes all the signs, doesn't it? So the easy way is just to do it in one step, minus 2x plus 1. Basically, this minus in the middle distributes to both of those, doesn't it? And so a very common mistake students make is they'll just put it on the front guy, but they won't let it hit the back one. So watch out, a minus sign in the middle has to distribute to both of them. And then it's good. Now we just combine like terms. Like good so far? See how that minus sign went to both of those? And then we say, okay, now the bottom again is just staying the same. What happens up in the top? 3x minus 2x. What's that? Just x, 1x, or just plain x. Either one's fine. And then 8 plus 1 now. It's actually plus 1, huh? It's going to be 9. And we're done. That's all there is to do on that one. Comment, question?
Just for the homework, is it going to be like...
Number 9's not quite as user-friendly. What's harder about number 9 compared to number 8 there? What do you notice about the denominators? They're flipped. Yeah, they're basically the same. They're just flipped. So what can they? So basically, we don't like x to be in the back, right? When things are subtracted, we want to take this one and flip it back to be x minus 5. But I can't just do that, or I would be changing the problem. Remember, in math, we're always making things look different without being different. I call it plastic surgery. Help you remember, we're removing the wrinkles, but it's the same person afterwards. So I want to change that without really changing it, I want to change the way it looks so it matches the other one, but I can't really change the value. If I switch the order of subtraction, that'll change the value, but there's a way to fix it. Remember what we learned? Yeah, put a negative 1 in the front. Then it's okay. If you do both those things, if you flip the order and put a negative 1 in the front, that's the same. Let me write that a little neater. And that's what we'll do. We'll just take this and we'll go, okay, flip it around and put a negative 1 in the front. Let me prove to you real quick that that's really the same now. If you were to multiply that minus 1 through, what would you get? Minus x plus 5, true. A minus 1 hit the x and the minus 1 hit the minus 5. Okay, and do you see how that's really exactly the same as the original 5 minus x? Now you might say, no, it's not. It's still out of order. Remember in algebra, it's a really important lesson right here. Order doesn't matter. Signs in front are all that matter. Remember that? That'll really take you a long way. Order, it doesn't matter at all really what order things are in. You can shuffle them around all day long as they have the same signs in front of them. Right? So do you see those? What's in front of the x? Negative. What's in front of this x here? negative, same thing. What's in front of this 5? Positive. What's in front of this 5? Nothing, which really, as you know, means positive. See how they are the same? The order doesn't matter. They're the same. So my point is, by flipping the order and putting the -1 in the front, I made something that's really the same as the original, but now it looks like the other one, making our work much easier. Everybody tracking with me? This is what you always do when something's flipped. Like that, when it's subtracted. By the way, what if it was added? What if I had like x plus 5 and the other one had 5 plus x? What if it was added instead of subtracted? Ours is subtracted. What if they gave me two of them flipped, added? What would I do?
You got a positive?
I would just flip it and who cares? Because the order of adding wouldn't change anything. I wouldn't need to put a -1 in the front in that case. Does that make sense? Because the order in which you add two numbers never matters, right? Think about just plain numbers. Is 2 plus 3 any different than 3 plus 2? No, it's 5 either way. So you can flip the order of adding all day long, who cares? But the order of subtraction, no, that matters. 5 minus 2 is not the same as 2 minus 5, is it? This one's 3 and the other one's -3. So when you flip the order of subtraction, you do have to fix it by putting a -1 in the front. Does that make sense? Just showing you that with numbers so you get the truth of what we're doing. So when you switch the order of subtraction, you need to put a minus in the front to fix it. If you switch the order of adding, who cares? You can do that anytime you want. Okay, so then, getting back to this problem, all that was just proving it's okay. Let's actually do it now. So I flipped the order and put a -1 in the front. Okay, what do I have now? I have 8 over x minus 5, and the next one now has been flipped, -1 in the front, and now they're both x minus 5, which is good. We want them the same, right? We've got to have the bottoms be the same so that I can combine the fractions, add the fractions, right? Now, one little maneuver left. I don't really want that -1 down there because I just want x minus 5. Do you realize I can take that -1 and let it float right to the top? And that's totally fine to do. You tracking with me? So I'm going to take that -1, I'm going to put it right up here and get rid of him from the bottom. Why? Well, think about, let me just prove it to you again. You notice how I always show things with numbers, right? Because x's are weird, but just think about numbers, and what's true for numbers is true for x's. So if you had like 8 divided by -2, what's the answer to that? It's -4, isn't it? Because, 8 divided by 2 is 4, and positive divided by negative is 8. You know that's true, huh? That's just -4. Well, what if you had the negative on the top instead of on the bottom? Do you see it's going to be exactly the same? That's still -4, isn't it? Right? Because, again, 8 divided by 2 is 4, and one negative just makes the whole fraction negative. So my point in that, am I making sense? The negative on the bottom or the negative on the top is the same in a fraction, isn't it? That's why it was okay for me to move it from the bottom up here to the top. Does everybody see why that's okay? I'm just proving to you with numbers that really is, again, plastic surgery, right? It looks different without being different. And it makes it easier for us to do the problem, to get that minus out of there. There's a million tricks like this in math. Not a million, but there's a lot, and I'll be showing them to you. They're all just plastic surgery, though. They all make something look different without being different, and they help you to do the problem. So, minuses, top, bottom of fractions, all the same. Move it wherever you want. So I just move it on up. All right, so what does that give us now? Well, now they have the exact same denominator. See, all that work was to make the two denominators identical. Common denominator, right? That's what all that was about. And now they are. So what do we have left on the top? 8 plus -x, right? -1 times x is just -x. You can leave it that way. That's fine. Or you can just say 8 minus x. That's the same thing, right? Both those are good. Math Excel will take either one. They're the same thing. Plus a -x is just minus x. On the top, 8 plus -x or 8 minus x. Same thing. Either one's a good answer. And we're done. What did we do? We took the two fractions, made the bottoms the same, so we could combine them into one fraction. Add them together to be one fraction. Questions on that one? And now these two denominators are just simply different, aren't they? They're not just, flipped or something. They're just completely different. Okay, So what do we do when you have two denominators that are totally different like that? Well, you gotta multiply top and bottom by the other guy, don't you? You seen that common denominator? So in other words, I gotta come to this one here, and I gotta multiply top and bottom by x plus 3, and I gotta come to this one here and multiply top and bottom by x minus 4. Does everybody see that? See what that'll do? See how that'll make both denominators the same, which is always our plan. Then this denominator will have both pieces, and the other denominator will also have both pieces. You basically give them what they're missing. You give them what the other guy has. But when you do it, you got to do it top and bottom. That way you don't change anything. It's plastic surgery again. It'll look different without being different. If you're doing the same thing to the top and the bottom, then it won't really change, right? Good so far? All right, now we just got to carry that out. All right, so the denominator is just x plus 3, x minus 4. I'm going to make it one big fraction. Once the two denominators match, we make it one big fraction, don't we? We combine them. So one big bar, common denominator. Doesn't matter what order. You know, you could put the x plus 3 first or the x minus 4. It doesn't matter at all. Now, what happens in the top? That's where the work is. This 6 is going to distribute. You can distribute from the right side just like you do from the left. Same thing. So that'll be 6x plus 18. Are we good there? The 6 hit the x, and the 6 hit the 3. Distribution. I distributed. We good? Now, watch out. Here's a really common mistake. Are you with me? Right here. This is a negative 4. It's not a regular 4. It's that negative. In fact, I would basically never subtract fractions. I would just let that minus go right up there on the 4, because that's who he really belongs to. He's right on the 4. Remember, a negative on a fraction, you can put it on the top or the bottom. I don't want to put it on the bottom because I'm already done with the bottom. I got that matching. I don't want to mess with the bottom. So I let that minus go to the top. Does that make sense? Remember, we just saw an example where we had a minus on the top of a fraction and on the bottom, right? And I showed you they were all the same. So I just put it on the top because I don't want to put it on the bottom. The bottom's good. Don't want to mess with the bottom. All right, so just put that minus on the 4 and then distribute. A lot of people forget. They distribute the 4, but they forget about his negative sign because it's way back here and you kind of out of your visual range. Watch out. Put that minus on the 4, distribute. Minus 4x plus 16, huh? And now we just gather like terms. So the bottom is x plus 3, x minus 4. On the top, 6x minus 4x. What's that? 2x. 18 plus 16, 34. Done. Questions on that one?
Do you factor the...
Yeah, on the top, it's not going to go anywhere. But you're thinking right, Caesar. If you factored out a 2 like that, yeah, good question. Caesar's wondering, probably some of you folks, some other people too. What about factoring the top? That's okay. It's not needed. You can do it. There's nothing wrong with it. It's only beneficial, like it's only required if it makes something cancel. Nothing canceled, so really, it's good either way. Both answers are right. Mathexcel will take either one of those. This is good. This is good. They're both okay. Both answers are good answers. Neither one's better. Factoring is only required if it makes something cancel. That's really the purpose of factoring, is simplifying canceling. And nothing canceled, so it's optional. Good?
Yep, going back.
Make sense on that one? So what did we do? We subtracted two fractions by making the denominators the same, right? We multiplied top and bottom by the other denominator. And that made the two denominators the same. And then we just carefully multiplied the stuff on the top, not forgetting the minus sign in the middle, and gathered like terms. All right. Why don't we try number 11? So that one is just like the one we just did. By the way, those x plus 3 and x minus 3, those are just different. You can't flip one around. They're just different. Even though they're somewhat similar, in the end, they're different. So let's do that one. Try that one on your own papers, and then I'll finish it up. X minus 2 over x plus 3. Yeah, so you got to multiply by the other one. So I got to multiply top and bottom by x minus 3. And on this one, top and bottom by x plus 3, like that. Yeah, so maybe it'd help if I write the steps too. Step 1, multiply top and the bottom, numerator and denominator, by, I'll just say what is missing, by the denominator that is missing. Okay, multiply top and bottom by what is missing. Only multiply out the tops. On the bottom, it's gonna be common. It's gonna be least common. It's common. Right? So is this making sense? I'm not going to actually FOIL the bottom. On the bottom, on step 2 here, I'm just going to write x minus 3, x plus 3. I'm happy with the bottom as it is. I'm not going to FOIL it. I'm not going to do any of that. But on the top, I am going to FOIL. That's what I mean by only multiply out the tops. On the tops, I'm going to FOIL it because I need to gather all the stuff from one numerator with the other. Whereas the bottoms, no, they're good. They're matching now. I'm happy with the bottom. Does that make sense? That's what we're always going to do. Only multiply out the tops. So that means this x will go to both, and then this minus 3 will go to both. Remember how that works when you have two things multiplying two things? First to both, second to both. First to both, second to both. So you get x squared minus 2x, and then he's done, and then minus 3x plus 6. Is that good so far? Oh yeah, this is a hard one. There's another tricky part. So that's all this numerator right there. Foiled out. Everybody see that? And now the second part, it's just so easy to mess up. Let me help you with that second one. That subtraction symbol in the middle right here, that thing's just deadly. It's almost the number one most common. If I was to do a top 10 list common mistakes, it might be number one. A minus sign in the middle between two fractions. So easy to forget about it. It's buried way back there and you have so much other stuff. So that's why I suggest, here's my suggestion. I'll make it step 0. And I might kind of add a room here. I'll put it step 0. I'll put it down here. Never subtract. Move the subtraction to the upper right. In other words, this minus sign, let him go right away on these guys, making it minus x and minus 5. Just let him go right away. That way you won't tend to forget about him later. Does that make sense? Remember, a minus in front of a fraction can go to the top or the bottom. I don't want to go to the bottom. I'm happy with the bottom. So I'm going to go to the top. But when it goes there, it has to hit everybody in that top, not just the one in the front. That's the common mistake. A lot of people put it just on the front one. Does that make sense what happened there? So I basically never subtract. It's hazardous to your health. It's hazardous to your algebraic health. It's just easy to mess up. So just take that minus and go boom, boom. Just go upper right. So whenever I have a minus sign, I just right away distribute. So then I've got minus x and minus 5. And now I'll keep going with the problem. So now this minus x. Let me get this, because minus x is going to go boom and boom. So that'll be minus x squared minus 3x, right? And then this minus 5 is going to go boom, boom. Minus 5x and minus 15. So that's all the stuff that came from these guys. Is that good there? It's just so easy to mess up the signs on some of that stuff. Now, can you gather like terms there? Just gather up like terms. Some stuff's going to cancel, huh? X squared and x squared is going to cancel. X squared and minus x squared, I should say, is going to cancel. Gather up the other stuff. There. So that means this guy's going to cancel this guy. X squared minus x squared. That's just 0. They're going to drop out. And then what else is going to happen? Well, with the x, like I'll combine minus 2x minus 3x, that makes minus 5, and minus 3 more, minus 8x. See what I did? I just combined all three of those, and then I'm going to combine, oh, and I forgot the other one. What am I doing? I forgot this one. And 5 more, what's that, 13? There we go. So I just add up all the x terms, right? And they're all negative. They're just like, think about a loss. Like if you lose $2 and lose $3, that's 5. 3 more, that's 8. 5 more, that's 13. And then 6 minus 15. The only things left was that minus 9. Yeah, minus 9 over x minus 3, x plus 3. We are done. So I just gathered like terms up there. Questions on that one? That making sense?
How'd you get 13?
All right. So that was number 11. Shall we try 12? X over x squared minus 8x plus 7. Plus 7 minus. And what was it? It was x over x squared minus 4x minus 21. There we go. Steps here for you. So step 1, or I'll call it step 0. Step 0, never what? Never subtract. Move minus. Move the subtraction to the upper right. So take this and boom, put it right on that guy. Does that make sense? So do that first. Never subtract. Just move that thing right there. That'll keep you from an easy mistake. Just put it right there. Okay. And then step 2 or step 1. That was just like a step 0 because you don't always have to do that. There's not always subtraction. Now, factor the denoms, with the parentheses. So this denominator is going to be 2 parentheses, and this denominator is going to be 2 parentheses. So that's step 1. They already had that done for us in the other problems. So factor those 2. You guys are pros at this now, right? That was last night's homework. Well, if you're pros, but you're hopefully somewhat comfortable with it. You're looking for, x is in the front. X is in the front. 2 numbers that multiply to be 7, add to be minus 8. Right? Same thing over here. Multiply to be minus 21, add to be minus 4. Use your calculator if you're rusty on some of those times tables. We good? So what 2 numbers multiply to be 7?
7 and 1.
I'll get to that one in a minute. So I'm doing the first one. So 1 and 7. And what signs do they need to add to be negative 8? Both negative, huh? Because if you lose $1 and you lose $7, you lost $8, huh? And the 2 negatives multiply to be positive 7, don't they? So that's good. Now, how about the other one? What two numbers multiply to be 21, Angie?
7 and 3.
Yeah, 7 and 3. Very good. 7 and 3. Yeah, now how do you know what signs to put on them? So first, notice I first put down the numbers, then I do signs. What's the rule for the signs? Bigger number. Sign in the middle goes in the bigger. So the sign that's in the middle, what sign's in the middle here? Negative has to go on the bigger. So negative has to be on the 7, positive on 3. Because if you lose $7 and gain 3, you lost 4, huh? And they do multiply positive times negative to be negative. So that's all good, right? We good? So let's kind of rewrite things. So that's all first step. So let me rewrite what we got. We got x over x minus 1, x minus 7. Oh, by the way, there's no longer a minus sign in the middle because I put it to the upper right. Does that make sense what I did? See how that sign in the middle is gone, so it becomes plus? I hope that's not confusing. All I'm doing, let me show you what I'm doing. If somebody gave me a problem like, I don't know, 8 minus 2. What's the answer to 8 minus 2? 6. Is that any different than 8 plus negative 2? Same thing, huh? That's all we just did there. It was subtraction. Original problem was subtraction. And I'm saying never subtract. It's just too easy to make a small mistake. Instead, add the opposite. See how we're just adding the negative x now? We're just adding the opposite. That's exactly like this. Adding the opposite is the same as subtraction, and that way we won't tend to mess up. That's all we're doing. So when I say never subtract, I mean let it go to the upper right, add the opposite. It's the same thing, and it's much easier. All right. We good here? We've been here before. You know what to do now, right? What's our next step? We got to get those two denominators to be what? The same, right? And so that means we have to give them what's missing, what the other one has that we don't have, right? So give them what they're missing. Let me get rid of all these extra marks here. So plus negatives. Okay, so like, so step 2, multiply top and bottom by whatever is missing. By whatever's missing, okay. So this one, top and bottom, what is the first denominator missing that the other one has?
X plus 3.
The x plus 3. Yeah, everybody see that? X plus 3, x plus 3. And then we come over here to the second one, top and bottom. What is the second one missing that the first one has? The x minus 1. He has the x minus 7, so just the x minus 1. Right, x minus 1. See how the two denominators are identical now? By just we just filled in their gaps, didn't we? We just gave them what they're missing so that the two denominators match now. But we did it top and bottom because you can't change anything. That way it doesn't change anything. All right, distribute out those tops. Now we're ready to make the next line. It'll be one big fraction, right? Because the two denominators match. Once you made the two bottoms the same, you don't need two of them anymore. Make it one big fraction. Common denominator. Multiply out the tops and gather like terms. How we doing? Is this good? So I'm going to, so here that's step 2. So now step 3, multiply out the tops. So just the tops, huh? Because the one big fraction. It's going to be one big fraction, common denom. We've made the bottoms the same. So it's one big common denominator. And I'm not going to multiply the bottoms, right? Because I'm happy with the bottoms, the denominators. They match. One big common denominator. That's all good. Don't need to mess with that. But the top, I do need to multiply things on the top. So this x will go to these two. X squared plus 3x. This minus x will go to those two. Plus minus x squared plus x. Did you see all the signs there? Got to be real careful on that. It's easy to make a small mistake on the sign.
It could be a 1x, right? Was it left of x?
Yeah, you can write that as 1x.
Okay.
That's good too. Yep, that's totally good and the same thing. In fact, I'll do that. 1x. Good, okay. So now, last step. Combine terms on the top, right? Combine the like terms on the top. So combine the like terms on the top. What do we have? So x squared and minus 8, those will cancel, won't they? So 3x and 1x is just 4x over the common denominator. X plus 3, x minus 1, x minus 7. There it is. Questions? Yeah, okay, so there's number 13. So let's go through those steps again. What is the step 0? Yeah, never subtract. Yeah, exactly. Good. Never subtract. So instead, add the opposite, huh? Take that minus sign and stick it right on the 2, and that brings it down as an adding problem. We're going to add negative 2 instead of subtracting 2. That'll be easier for us. So that'll become a plus in the middle and a minus 2 there. So that's the 0 step, so to speak. Okay, and then so what's our next step now?
Factor out the 2 squared minus 1 and dividend squared.
Yeah, factor those two denominators, huh, with the parentheses like we did in last night's homework. So factor with the parentheses those two denominators. I'm going to try to step through it step by step for you. So the two parentheses, right? Remember what we learned? This is actually a difference of squares. That's exactly right. Was it Michael that was saying that? Difference of squares. That's exactly right. Where those are the kind where you have x's in the front. X times x makes x squared. And what goes in the back to make negative 1? Positive 1 and negative 1, huh? Because positive 1 times negative 1 makes that negative 1 in the back. Remember that kind? So that's how that factors. And then this next one is 3 terms. Remember how the 3, you put x's in the front for the 3-term factoring. And you say what multiplies to be negative 2 and adds to be the number in the middle. What number is in the middle? Plus 1, huh? So what two numbers multiply to be 2? Yeah, 1 and 2. There's really no other option. So 1 and 2. And then remember, notice how I always write the numbers down first, and then I put the signs on after. What signs do they need to add? Remember, the sign in the middle tells us the story on the signs, doesn't it? The sign in the middle goes on the bigger. Goes on the bigger. Plus 2 minus 1 will make plus 1 in the middle, won't it? And they'll multiply to be negative 2. Like that. Is that good there? So that's step 1. Factor the denoms with the double parentheses. All right. So that was step 1. Step 0 we just did. And now we're on to step 2. And so next, you're going to multiply top and bottom. By whatever is missing. So multiply top and bottom of the left fraction and top and bottom of the right fraction by whatever's missing, whatever the other denominator has, to make them the same. You want to make common denominator. You want to make the two denominators the same. All right, so I'm going to bring it down and multiply by what's missing.
On the back of the book, they took out the common denominator on the top.
What'd they do?
They took out the common denominator.
Oh, yeah, you don't have to do that. That's optional. Let me show you. So I'll show you when I get there. So, all right, so I'm going to multiply top and bottom by what's missing. So I go to the first one, and what is this guy missing that the other denominator has? X plus 2, right? And then the second one, what is he missing that the other one has? X plus 1. We good there? See how the two denominators are the same now? So we go on to step 3. And now on step 3, multiply out the tops, and you should have one big bar common denom. So we're going to have one big bar with all the same denominator, x plus 2, x plus 1, x minus 1. Doesn't matter what order you have those in. As long as you have those three pieces, the order doesn't matter. On the top, though, we have to multiply things out. This 4x is going to go boom, boom. 4x squared plus 8x. And the minus 2, boom, boom. Minus 2x minus 2. Good to there. And the fourth step. Combine like terms in the top. So 4x squared is all by itself. 8x minus 2x, what's that, 6x? Minus 2 over x plus 2, x plus 1, x minus 1. Now that's a fine answer. I know the back of the book factored a 2 out of the top. You don't really have to do that. This is a great answer. Math Excel will take it. It'll give you full points. It's totally fine. If you happen to notice that you can take a 2 out of all those terms on the top, leaving 2x squared plus 3x minus 1, that's okay also. It's really not needed because it doesn't make anything cancel. Remember when I was saying that a minute ago? Factoring, taking something out of the parentheses, factoring is only helpful if it makes something cross out, cancel. So we don't really care about this. It doesn't really do anything for us. It's not really needed. So either one, this one or that one, both are good, both are right. Math Excel will take either one. On the multiple choice exam we take, whatever it is, next week, or no, week after next, on Tuesday the 4th, week after next. Either answer could be on the multiple choice. Grab either one. They're both right. It won't give you both of them. It'll probably be the first version. They probably won't do the extra factoring. Questions on that? How are we doing? It's making sense on that? So notice how in math, studying math, algebra especially, college algebra, is just like learning a language, like Chinese or something, right? So you have to learn every step. So like, for example, in that first step, I'm factoring denominators, which was last night's homework, right, with the parentheses. So if you didn't really master last night's homework, you didn't get it done, or you kind of did it, but you don't really have it, then today is really hard, and then this is how people get in trouble in a math class. It's just like a language, huh? To learn a language, you have to learn each step. You can't go on to Chinese 3 if you didn't learn Chinese 1 and 2. That's exactly it. So every night, every homework assignment is super important that you really learn it, like factoring, because we're going to use that. The parenthesis thing, we're going to use that in all these problems. So what I'm saying is, if you have any trouble, you really have to go see our tutor, come to my office hours, use the YouTubes, do whatever it takes to really get that down, because it's going to be used in the very next lesson. As long as you master every step, it'll all work out. But at any point, if you lose a step, it'll be trouble. Yeah?
Did we find out what days we're going to have tutor?
All right. Good. Let's go on. So any other questions I can answer on that one? That all good? All right. Let's go on then to what number? That was number 13. Let's go to, should we go to 14? Yeah, I guess it's a little different. Okay, so 14. Okay, yeah, so there's number 14. So this one's kind of nice. It's like halfway done, sort of. It's already got the denominators factored for us, right? So you can skip that step, and it's adding in the middle. Nice. It's not subtraction. This should be a little bit easier one. So it's not subtraction in the middle. We don't have to worry about that moving up the minus sign thing. And the bottoms are already factored. They're already parentheses, you know. So just jump right into the step where you multiply top and bottom by what's missing. By what's missing. You want to make those two denominators the same, right? Common denominator. What's that first one missing?
X plus 2.
Yeah. Well, he just needs one of the x plus 2's, right? Because now if you just give him, right, because this guy had squared, and he only had one of them, so give him one more, and now he's got squared also. Does that make sense? Everybody see that? So the one on the right had x plus 2 squared. The one on the left only had a single x plus 2, so we just give him one more x plus 2, top and bottom. We always have to do top and bottom.
Oh.
Now he's got two of both things. Does that make sense? And then you go to this guy. Now you go to the one on the right. Yeah, you're getting it. He only has one x minus 2. The other guy had x minus 2 squared. So we have to give him another x minus 2. Got to be top and bottom. Always a fraction until he's top and bottom. So nothing changes. X minus 2, x minus 2. And then we take it from here. So that's the step. Really, it's way down on step 2 or whatever, huh? Because we got to skip the factoring step, huh? The bottoms were already factored. Multiply top and bottom by whatever is missing. So there's that step. We multiplied top and bottom by whatever was missing. Okay, and now step 3. Multiply. I'll change the color here. Multiply out the tops. Right, so this 2 is going to go boom, boom. 2x plus 4. And it's just one big bar now, huh? One big bar because it's a common denominator. I don't need to. What is the denominator? X plus 2 squared, x minus 2 squared. It doesn't matter what order. You can put the x minus 2 squared first, and it doesn't matter. But you see how they both have the same denominator? One big bar because it's a common denom. By giving them what they were missing, the two denominators have the same stuff now. Right? Like if I went and got one of those fancy cars my neighbor has, and he went and picked up 4 more kids, and we'd have all the same stuff. Yeah.
Can you just tell me that we can't?
And on the top, so we multiply that out, plus, and then the 5 is going to go boom, boom, 5x minus 10. Is that making sense on that? All good there? And basically, we're almost done with this one, huh, at this point. And now you just like terms on the top, huh? Like terms on the top. Step 4. So, yeah, 2x and 5x, 7x, 4 minus 10 minus 6. And the bottom, x plus 2 squared, x minus 2 squared. There, that one's good. You good there? All right, so on to 15. 15, 6 plus 1 over x all over 2 minus 1 over x. 15, notice, let me write the form here. This is fractions over fractions. We call that a complex fraction. That's the name of it. It's fractions over fractions, the technical math name. That big old thing is a complex fraction because it's got fractions over fractions, which is pretty ugly. So we need to clean it up. We just simply, what do we want to do here? What are we even trying to do here? We're trying to make it simpler. Trying to make it just a normal fraction. We don't like fractions over fractions. That's just ugly. We want to simplify it. This is what they do in math and science. When they're doing chemistry, physics, biology, they get messy expressions like this, they clean them up. So I want to clean it up. So how do you do that? So we just changed gears. Did you feel the shift? Right? We just changed gears. This is not two fractions added or subtracted anymore, is it? We're in the same section. but we just changed gears. This is fraction over fraction. Fraction divided by fraction, not two fractions added or subtracted. So what do you do when you got fraction over fraction, complex fraction it's called? What do? The most important step is step one. You multiply every term, top, and, well, let's do this. Multiply, no, sorry guys, keep changing my mind. I want to get it exactly right. Take one of every item under a bar. That's going to be the LCD. So what are all the items under bars? Well, X, and X. That's it, right? That'll get a little fancier, but for this one, it's the only thing under bars. I mean, other than the big bar, the little bars, the only thing under the little bars are the X's. Take one. Now, I'm only going to take one X. I'm not going to take 2X or X squared. That's why it's important that I wrote take one of every item under the bars. So just a single X. Okay? Now, if there was more to it, like, for example, in a minute, they'll make this 2X and this 3X. Then I would take the X, the 2, and the 3, which is really 6X. Getting the idea? So if there was other stuff than just a single X, then I would take that extra stuff. Again, the rule is one of every item under a bar. So if there was a 2 and a 3 and an X, I would take them all and multiply them all together. 2 times 3 is 6, X. But in this case, all we have is X. There's no 2's or 3's. There's just an X. So, all right, X. And what do you do with that now? Now, multiply every term, top and bottom, by that LCD. That's called the LCD, the least common denominator. So multiply every term, top and bottom, by that. Let me make this a little bigger so we can see what's about to happen here. So 6 plus 1 over X all over 2 minus 1 over X. Okay, so now I'm going to do that. I'm going to multiply every term, top and bottom. So that means this guy, the 2, and the other 1 over X. So the 6 and the 1 over X, the 2 and the 1 over X. Every term, top and bottom, by that LCD, that common denominator. That's legal to do. It's fancy plastic surgery. It'll look different when we're done without being different. Why? Why won't it be different? Because I did the same thing top and bottom of a fraction. I did the exact same thing to the top and the bottom of a fraction.
Will the X's translate to Y?
Exactly. Yeah, that's what'll happen. Now remember, this X is really over 1, isn't it? Anything alone is really over 1. So these guys will cancel and these guys will cancel. That's why I'm doing it. I want to get rid of those extra fractions over fractions. Okay, so what does that leave us now? 6X, right? Because this is 6X here. Plus 1. It's a big 1. Because these X's canceled. Over 2X minus 1. Do you see what happened there? See how it canceled those X's? Just left a 1 in both those cases. And we're done. There's nothing else needs to be done on this one. So what did I do? Fractions over fractions, complex fraction. I looked and I took one of every item under a bar, which was just X in this case. And then I multiplied every term, top and bottom, by that LCD, X. And canceled it. Hey guys, let me ask you this question. Well, first off, do you have questions that I can answer on that one? Okay, why can't I go 2X goes into 6X 3 times? Isn't that true? 2 goes into 6 3 times. X is canceled. Let's cancel the X's. 2 goes into 6 3 times. That's wrong. Why?
It's the whole package.
Yeah, the Costco thing again. So I want to keep reminding you that, right? Because they're plus. Now, if that was times, if up here and down here, if they were times, that would be great. I could totally do that, and I would do that. But remember, pluses and minuses are package deals, like shopping at Costco. They're glued together, which means they say take all of me or none of me. Don't just take the 6x part and leave the 1. You can't do that. You buy them both or nothing, right? And we can't take them both, so we don't take nothing, to use bad English. We don't take anything. So 6x, 2x, we're just done right there. That makes sense? Why we can't cancel further? Package deals. All or nothing. We can't cancel them all, so we cancel nothing. Come back in the break to the next one. We'll see. 16. 2 minus x plus 9 over x. 9 plus x minus 9 over x plus 9. Okay, so it's a complex fraction. Fractions over fractions. What do we do? Remember step 1? Let's look back here. What was step 1? Find the LCD. And how do you find the LCD? One of every item under bars. So, number 1, LCD equals one of every item under the bars. So what's under the bar? Solo x and x plus 9 glued package. X plus 9 glued package. Remember, now again, pluses and minuses, glue stuff together, shopping at Costco, package deal. Okay, so why is that such a big deal? Well, that means that in this case, our LCD will be x and an x plus 9 package. Need them both, don't I? Because they're different. Now, let me give you, here's what they're going to do to us in a little bit, which is sometimes hard to see the difference. If instead they made this 9x, what would that change? Well, if it was just 9x, that's not a package. 9x is just solo 9, solo x, not glued together, right? If there's no plus or minus, they're not glued together. Well, so what? Well, that means when you're going to take one of every item in the store, you would take 1x, you'd come down here and go, I don't need that x, I already got one. I just need the 9. And the LCD in that case would just be a solo 9 and a solo x, 9x. I wouldn't need the 9x and the other x in that case. Why would you need 2 solo x's? You only need one of every item. See the difference? If they're solo, that would change things, wouldn't it? Because we're just taking one of every item. So if they're not glued, you only grab 1, 9, 1x. But if they're glued, if it's 9 plus x or x plus 9, whatever, same thing, put it back the way it was, x plus 9, then that's a package. I got to have that whole package, and I've got to have a solo on its own x, because those are different. And you can't say, well, I don't need the x alone, I've already got it in the package. No, package is a different deal. See that? See how important that concept becomes? Does that make sense? That difference? Because they'll give you both varieties. All right, so there's our LCD, one of every item that's under the bars. And now what do we do with that LCD? Multiply all the terms on the top and the bottom, all 4 of them, by the whole LCD, x plus 9. So it's going to be x plus 9 on the 2, and x plus 9 on the second fraction, and x plus 9 on the 9 on the bottom, and x plus 9 on the other fraction on the bottom. All 4 of them. Every term, top and bottom. That way it's legal. That way we're not changing anything because we're doing the same thing to all the terms, top and bottom. And remember, this thing is over 1, isn't it? Over 1, over 1. Step 2. Multiply all terms, top and bottom, by that LCD. So, this is the bar here. All right, so now cancel stuff out, right? You're supposed to cancel. When we're done, it's going to become a regular fraction. We're going to get rid of the ugliness. Get rid of the fraction over fraction. Make it a regular fraction, no longer a complex fraction, right? So what's going to happen? This solo x, oh, I did the wrong one. Let me try that again. I'm going a little quick here. This solo x and this solo x cancel, don't they? Everybody see that there? What happens over here? Well, those just go next to each other. So it's just going to become 2x, x plus 9, which I will multiply out in a moment, minus what's left over here? X plus 9, plus 9. Over. Everybody's seeing, am I going too fast? See how this had an x plus 9 and another x plus 9 left over, and these x's canceled, right? Did you see that?
Why did we show the 2 in the x plus 9?
I will. Just a minute, I will. I just didn't want to do too many things at once. But yeah, we need to, and we will in just a second. On the bottom, I'm going to put all these in. Now, I like to put the numbers in the front. Just makes it easier. It's going to be 9x, x plus 9. Right? I just put this 9 and this x in the front here. Just make it easier. Plus, and here, x plus 9 and x plus 9 cancel, don't they? And it's just 1 times x minus 9. Or I'm sorry, x. What am I doing? X times x minus 9, right? X minus 9 and x. Are we good to there so far? See how it's already a normal fraction? It's not fractions over fractions anymore. We got stuff to cancel. Does everybody see that first step? Okay, now, just cancel out. I'll just cancel those guys out. That good? That's fully illegal. So everybody, that's a really common mistake that students make. Even calculus students do that a lot. I'm always telling when I teach calculus, no. Costco glue, right? If you got minuses and pluses, like this right here is saying, hey, this numerator's all glued together, which means if you want to cancel any of it, you buy the whole package. You go like this, say, I'll take the whole numerator, please. Well, I can't do that. Right, so you can't do anything. Remember? Don't ever forget that rule. Pluses and minuses glue things together, making them a package deal. Meaning if you want to you want to cancel anything, you cancel it all. Or you cancel nothing. It's all or nothing like Costco. Well, we can't cancel it all, so we cancel nothing. You can't just say, I want just the x plus 9 part, please. No, not when you got a minus exposed or a plus exposed. They're glue. If that was times, if this was a times dot here, then that would be great. Well, and the bottom would have to be times also. Anyway, now I messed up the whole thing, didn't I? I just want to emphasize that strongly. That just brings down so many students. So 2x, x plus 9. Go back to where we were here. X plus 9, x plus 9. 9x, x plus 9, plus x, x times x minus 9. Okay, so what are we going to do? Just multiply and gather like terms. It's just a big multiplying mess. So just multiply out the top and the bottom. Now this time you might say, well, you said don't multiply the bottoms for. Yeah, well, this time we have pluses. Whenever you have pluses and minuses loose like that, you need to multiply everything out and gather like terms. Do you see the difference? If you look back here, see how like on this one, there was no pluses or minuses loose in that denominator? Huh. So nothing more needed to be done with him. See the difference? But when you got pluses and minuses, like here, then you gotta multiply things out and gather like terms. So we gotta do that. So let's do that. So that means 2x goes boom, boom. I'm going to get 2x squared plus 18x. Now this is going to be so easy to mess up. You see this minus sign? He's going to change the signs on all that stuff over there. So I'm going to FOIL it, but it's all going to be negative. Minus x squared, minus 9x. And then this guy goes to both. Minus 9x, minus 81. All those signs were changed by that subtraction in the front. So easy to make a mistake there. On the bottom, same thing, distribute. 9x squared plus 81x. And this will distribute plus x squared minus 9x. This problem's getting messy. All right, let's gather like terms now. I'm hoping we're almost done here. It's good so far. I just multiplied all that out, and I'm going to gather like terms. X squared stuff with x squared stuff. regular x stuff with regular x stuff and numbers with numbers. Here we go. 2x squared minus understood 1x squared, right? 2x squared minus 1x squared. That's just 1x squared or just x squared. Right? 18x minus 9x minus another 9x. Cancels. That's 18 minus 18. Bye-bye. Minus 81. That's all we have there in that top. Good so far. Now down here, 9x squared plus 1x squared, 10x squared. 81x minus 9x, what is that, 72x? I think, right? Yeah, 72x. How are we doing? We good so far? Really, we're done. Although the top and the bottom can factor, it won't cancel anything, so it doesn't matter. This is a fine answer right here. But let me show you. I'll show you the details of why it doesn't matter. You really could factor that top right. That's the difference of squares, x plus 9, x minus 9. Now bottom, how do you factor that bottom? What do they have in common? Remember, that's what you always look for, what things have in common. What do they have in common? What goes into both those? 2 and x, 2x, right? Put a 2x in the front, leaves 5x, because 2x times 5x would be 10x squared, plus 36, because 2x times 36 would be 72x. So you could do that, I'll say, or, you see nothing cancels? See how nothing cancels? So it doesn't really matter. Factoring is only matters if it makes something cancel. Nothing cancels. So either one of those two is a good last answer. You tracking with me? This is a fine answer, or this is a fine answer. Both are good. Math Excel will take either one. Look for either one on a multiple choice test. Both are right.